I'm going to explain about modeling of a transistor. As you know that the transistor is acted as an amplifier. So if you take this as an amplifier, it is having source, gate and drain terminals. So what is the application of the transistor? As you know that. So while giving the input signal, it amplifies the given input signal. This is the final application. Of course, it is acted as an switch, and by using this we can store the data. We can store the information, and we can control the input output signals by using a transistor. Control of input comma output signals as. And one more application is it is acted as an amplifier. So these are the applications by using a transistor, MOSFET transistor. Even if we take BJT, bipolar transistor, so by using this we can control input outputs as well as it is acted as an amplifier. So here for this transistor, what is the small signal analysis we need to find? Means for a transistor, what is the input impedance? What is the output impedance? We need to find. So small signal analysis we need to find. So for that I am taking this, you can see this, it is having source, gate and drain terminal. So the equivalent analysis for what is the transistor? So just assume this is the amplifier circuit, that is VI input side, and this side is output side. So here the equivalent, what is the output equation across the output current across the transistor is, this is an transistor current. We need to draw like this, GM into VGS. So this is the transistor current ID. So as you know that the transconductance GM equal, that is output voltage, output current at the drain and source divided by, that is input voltage VGS. So if you cross multiplied here, then IDS equal, that is GM into VGS is the current. So like that we can write, this is the current in the transistor model output side, and remaining what is the input? So this is what is the input here, and here it is an output, and here the input voltage is VGS, voltage between gate and source, voltage between gate and source. This is an VI. So or else input impedance if you want ZI, that is named as. So this is the small signal model, small signal analysis. So then we can write what is an ZI. So ZI equal VI into II. Input impedance, that is equal input impedance, that is VI by II. So but VI equal, that is II into RI by II, input current. II cancel RI. But what is an input impedance across this? Input impedance is, that is internal resistance we need to find. So it is having, this circuit is having some internal resistance. That internal resistance equal to Ri. This is an internal resistance. This is the input impedance for the given transistor model. Input impedance. Like that, we need to find output impedance for the circuit. So Z0 equal output voltage by, that is output current. But what is an output voltage? I0 into R0 by I0. I0 cancel. So that is equal to R0. So R0 is the output impedance or else internal resistance for the transistor. So like this we can find the current, and here if you want voltage gain is equal AV, that is output voltage by input voltage is the voltage gain, or else I naught into R naught by, that is IA into RI. So I naught by IA is the current gain, we can write it as AA, and R naught by RI. So like this we can find the parameters, that is input impedance, output impedance for the transistor, and voltage gain. So but finally the application is, that is it should be acted as an amplifier switch and stores the data, control the input outputs. Thank you.